Okay, so we're going to look at some terminology. These are some keywords that we will be using throughout the lesson that I want to ensure that you know. And the first one is an exponential function. So an exponential function is a function in which the independent variable is an exponent. So normally the independent variable we look at is the variable x. And you'll notice that in the exponential function, that variable happens to be the exponent. Typically we see it as being as part of the equation where you might have something like y equals 3x squared. So you'll notice that the variable is part of the statement. The independent variable is part of the statement, but now we're going to see the independent variable as part of the exponent. Okay? So we have y equals b to exponent x, where b cannot equal 1 and b is positive. So there's two conditions on the value of b, b representing the base of the function. The first condition is that you can't have b equal to 1. And if you think about what happens if you substitute in 1 for x, for the base, you have 1 to the exponent x. Now, I know that no matter how many times I multiply 1 by itself, which is essentially what's written here, if I multiply 1 by itself, doesn't matter how many times, the result in this case is 1, always. So this doesn't actually represent exponential functions. It doesn't model an exponential behavior, so it doesn't show growth or a decay. What it actually shows is a horizontal line through y equals 1. So it actually represents a horizontal line when you have y equals 1 to exponent x. So this is not an exponential function. Okay, it doesn't model the behavior of an exponential function. Okay, the other condition is that b has to be positive. Now, I want you to think about what happens if you had a negative base. So let's say you had y equals negative 2 to the exponent x. Now, at home on your own, what I will have you do is try substituting in different values of x. So for example, plug in x equal to 0, 1, 2, 3, 4, and you'll see that this really awkward pattern is created between the points. Okay, it doesn't again show an exponential growth or decay. So that's something for you to try out. Okay, some other words that you might hear are increasing function and decreasing function. So an increasing function looks at as the independent variable increases, the value of the function also increases. So in other words, as you go across, so as I go from left to right in a graph, then the actual function increases as well. So as x increases, y also increases as well. So you might have something that looks like this. So as the value of the independent variable is getting higher, so is the value of the dependent variable. Okay, a decreasing function is slightly different. As the independent variable increases, so as I move across from left to right along the x-axis, then the value of the function is decreasing. So in other words, if I were to sketch a graph of a decreasing function, it means as I move across the x-axis from left to right, the actual function is getting smaller in value. So it's a decreasing function. Okay. So we are going to be looking at the properties of the exponential functions that you did in the investigation. So get out your investigation. We're going to be looking at that as part of the lesson today.